Hello friends, welcome back. So we were talking about the cumulative distribution function, CDF as a name defined. Cumulative means a word which is being derived from the word cumulative distribution, and cumulative means when we calculate the all the pending values, and we keep on calculating the previous values also, then that is known as cumulative. So here this cumulative distribution function shows that whenever we have to determine the probability of any current specific value, we also take into account all the previous values or from the last to the latest. This is the philosophy, and we denote this cumulative distribution function by using the function capital Fx, and the symbol is very simple. It is p. Wait a second. As it was p x equals to x in our PDFs, and in PMFs we have p x less than equals to x in our CDFs. CDF value always lie between 0 and 1, and it has a range of 0 less than equals to 1. 0 is fx is less than equals to greater than equals to 0 and less than equals to 1 when fx is the nothing but it is the cumulative distribution function. Now we are going to have some questions about the CDFs also later on, so need not to get worry about this particular point. We are going to have a lot of questions in our classroom classes of PDFs and PMFs. It's just a theoretical point, and we are going to cover a lot of questions, and via programming also and via classroom classes also. Need not to worry about that. So expected value is nothing but it is mean. Well, if you want to go for the machine learning courses from here, then you will going to have the expectation. Lot of time it will come in front of you, so you don't get confused with the expectation. Expectation is nothing but it is the mean. Mu x is known as expectation. It is basically in the descriptive analysis or in the descriptive statistics. Mean is simple to calculate. We calculate them by summing up all the values and dividing them by the total number of values. But in this predictive analysis, where we do some type of prediction about that particular random variable will belong to the distribution or not, or what is the probability to have this particular value in your distribution, then there we use this expectation keyword for a random variable x, and we calculate its mean mu x, which is nothing but it is x into px, where px determines the probability of attaining any particular value by that random variable. Means again I will going to repeat, suppose a random variable random variable small x can attain any of the followings of the following values from a domain D. Means D is a big domain, and random variable x can attain any of these possible values. Then px is the associated relative probability of the occurrence of that particular value. Okay, means that x has to attain a particular random variable from random value from the set D, but what is the probability of attaining that particular value is being determined by the expected value x. That's why because it is prediction, we are talking about predictive statistics. So predictive statistics is being determined in this particular way, where here you use the keyword expectation of x for the mean, right? Now look at the example of the expected value. We have a data we are given below. We have the some expected number of credit cards that a customer to a retail outlet will possess, and x is the random variable which determines number of credit cards a customer can possesses, and what is the probability that a customer can have 0 credit cards. In the variable is discrete, so we are calculating the expected value for the discrete random variable. Okay, because we cannot have 1.5 cards, we cannot have 2.5 cards, we cannot have 3.5 cards, right? So x equal to 0, a person can have no cards. Its probability is very low, it is just 8%, and then 1 card 0.28%, 2 cards 0.38, 3 cards 0.16, 4 cards 0.06, 5 cards 0.03, 6 cards 0.01. Then we are going to calculate the expectation value, which is, of course, I have told you earlier also, the summation of x into its probability of attaining the particular value. It has been given by x1 p1 plus x2 p2 and so on to xn pn, and then we just sum them up by multiplying them. We get 1.97 is the overall probability of attaining. It is the overall probability value that shows that what is the mean. Here we calculate the mean, that what is the overall mean of having the number of cards by a customer. So it is being determined that a person can have mean 2 cards. Okay, they have used, of course, they have used the ceiling function, and so the total number of mean value of the cards is 2, that a person can have at least 2 cards with them. With this data we can say this. So in this way we calculate this. Okay, to calculate the mean value of a random variable, we use the keyword expectation. Okay, to calculate the value of a static variable, we use the simple mean formula, that is known as the sum of the values upon n. Please note this carefully. Then the standard variance and standard deviation. Now same thing is there for static variables. We have different formula altogether for calculating the variance. For random variables, we have different formula altogether to calculate the variance. Here we are talking about the random variables because we are talking about the distribution. So we have altogether different formula, and the formula for variance is very simple. It is nothing but x minus mu whole square into px. If you remember the formula of the variance for the static variables, what was that? That was simple, x minus mu whole square upon n. Then same thing is there, but here with the thing has been changed. It is being multiplied with the probability. And where what is d? D is the domain, as we have told you earlier also, that it is the total number of possible values which a random variable can attain. Remember this thing in your mind. So let's put this in this way also. It is ex, it is nothing but it look like ex minus mu whole square. It is just a way to represent the variance in terms of expectation. This variance Vx is equals to expectation Ex minus mu whole square. Okay, the standard deviation is giving y sigma square x under root. Have this example, please concentrate on this example also. It will going to give you the idea more clear. So we have some quiz scores out of a particular value. Same as I can sense that it is definitely be out of 30 or out of 30 or maybe out of 25, whatever. See, because since lower upper limit it is not given that out of which, so we will not going to concentrate on that. Let us have some series of some scores of a quiz, and let us calculate their variance and standard deviation. Since x is a random variable, now the random variable name is score, quiz score. It can attain any value, so we are going to calculate it using the probability of its attaining. So look at this table. Table has value of 12. The probability of having the total frequency of having 12 is 1. Frequency of having this 18 is 2, 20 is 4, 22 is 1, and 24 is 2, and 25 is 3. So what we will going to have there, we have, what are the random variables we have? Random variables are 12, 18, 20, 22, 24 and 25. So of course we have their probabilities also with associated with them. It is 0.08, 0.15, 0.31, 0.08 and 0.15, 0.23. Well, this is the data. If we can, I think that they have definitely calculated it by dividing them with the total number of values. And even if you don't have there is no problem with that. You can have if they have taken from the sample also, maybe this is sample they have taken from the population also, so it is not a big deal. So now calculate this calculate this variance and mean also. Mean is given as 21, it is given to us, or no problem with that. We have to calculate the variance. We can also calculate the mean by multiplying this value 12 into 0.08 into 18 into 0.5, 20 into 0.31, 22 into 0.08, 24 into 0.15, 25 into 0.23. We can calculate mean in this way also, but since they have given, they have definitely have calculated the static mean. No problem with that. If they have given, we just calculate the variance by using this formula, and this is the answer. And this way we have calculated it. Please do it by yourself also. It is going to give you the nice insight of the different parameters which we used to calculate in our distributions. This is the properties of expected values that please look at them. They are self-explanatory, and they are in fact not only self-explanatory, but I would like to say that they are relatively very important. Okay. Now, standardized normal distribution. So, come to the most awaited topic, that is known as the normal distribution. So, as far as the normal distribution is being concerned, we talk about the normal distribution is concerned, we talk about the normal distribution curve. This is the curve of a normal distribution, and this is our relative mean known as mu, and while I will have, if you will this is your mu, and of course we are going to have this score. Okay. So, let us now move forward. Look at this formula. The formula for standardized normal probability density function is f x is equals to 1 upon 2 pi e minus z square upon 2. This z can be written as, in this way we can also write in this way also, e minus x minus mu upon sigma whole square 1 by 2. Okay. This I have explained in great detail in the video lecture also. So, you need not to worry about this at this moment of time. f z equals to 1 upon 2 pi e minus z square upon 2, and z can be replaced with our favorite formula, which we know it is nothing but x minus mu upon sigma. So, you can now recalculate this formula with a great ease, no problem. If x is distributed normally with the mean of 100 and standard deviation is of 50, then calculate the value of z. Okay, then we can calculate the value of z also in this way. 200 minus 100 upon 50, it is 2.0. Okay. Similar, this says that when x is 200 and the mean is 50, then 200 is 2 standard deviation, that 2 increments of 50 units above the mean 100. Means when we do 2 standard deviation 50, we know that, and we know that in our normal curve this is 1 standard deviation and this is 2 standard deviation. So, they are saying that 200 which is lying here is 2 standard deviation away from the mean. Okay, where mean is 100 and it is 200, then it is 2 standard deviation. This is 150 and this is 200, 2 standard deviation away. Please keep this thing in mind. This is a way to calculate a probability of a this is a way to calculate the probability of a particular domain from A to B, and it is also relatively very easy to calculate. And this is normal curve showing, maybe you are aware about this also. They say the area is divided into two parts, it is 0.5 in this part and 0.5 in this part. Detailed normal curve is being explained in your video class, please go and see there. Okay, this is just an introductory presentation. Whole detailed concept is being told in your video class, please go and see there. Same thing is there for finding probability. Now suppose, now let's have a question. Let us have a question and calculate this value. Basically, I would like to repeat it again, that this is an introductory basic course of data analytics. You're going to have the test cases of the data also. You're going to have the exploratory concepts of the data also. You are going to learn how to build the models, but also you're going to have the deep insight of the statistics. Each and every minute detail is going to be touched, not just like blindly making the models is going to be there. So you have to devote your time to learn. Don't just go for the models, go for the concepts also. Let x represent the time taken in second to download a file image. Is there, suppose x is a random variable, which is nothing but it is a time taken to be taken in seconds, means we have associated x as time taken to download a particular variable, to a time taken to download a particular image in seconds. X is a normal distribution with mean is 8.0 and standard deviation is 5.0. What is the probability of p less than 8.6? Now look at this 8.6. This is the point to be noted. Okay, sorry. This is a point to be noted. Look at this 8.6. Okay, this simply shows that the range is that we are talking about the left tail test. Okay, so we have to calculate the probability of this particular region, and for this what we have to do is that we have to calculate the z value, and then we will going to compute the p value. Okay, so z is 8.6 minus 8.0 which is going to be 5.0, and which is going to about 5.0 going to be 0.12. So 0.12 is this one. Okay, 0.12 is this one. So probability of z less than equal to 0.12 is to be calculated is relatively very easy, because this is 0.5 already we know this particular portion. Please remember, I like to say this one. This particular portion is already 0.5 we know, just have to calculate this particular portion only. Okay. So look at this particular portion. P is less, this is how we are going to calculate it. 0.12 is nothing but 0.478. 0.478 it is written in the table. Why? Because they have already included this. They have already included this in the table. Now what is this particular area? This particular area which we were talking about, is being given as 0.547 0.500. It is nothing but 0.0478 is the area. Okay, or we can say that it is nothing but it is the 4% of this whole curve. Okay. In this way we can also calculate x greater than 86 also. It has been calculated just by subtracting the less than area, just reverse and subtracting this whole from where, from 1.0, and we get this answer. Very easy to calculate the range. Okay, this one which we have calculated earlier also, this can be done also very easily. Look, we have done this, we have done this in our last to last slide. Okay, great. And the end. Thank you very much for this lecture, and now proceed to our classroom section, we are going to have the more detailed analysis of the normal curves, the different type of distributions we are going to see, and then we will going to have the practical demonstrations where we are going to deal with the practical examples of these things which you have learned in your classes. Thank you very much.